Alright, so last time we actually got done the graphs of sine and cosine. So let me just sketch those quickly. Do a quick sketch of both of them. So the sine graph, again, so this is something you're going to want to remember, just stick in your head. Looks like that, right? The cosine graph looks like this. And we have some idea of what they are. Let's get an even better idea. So I'm going to teach you a trick to remember some of the values in the first quadrant of this, between 0 and 90 for each of sine and cos. Sine and cos. So they are, this is a really useful trick. Right, so we're going to consider the values 0, 30, 45, 60, and 90. Notice the symmetry about the point 45 here. And what I'm going to do is I'm going to write down the sine of each of these angles and the cosine. Okay, so sine of 0 I know is 0, cos of 0 I know is 1, and the opposite kind of happens over there. Sine of 90 is 1 and cos of 90 is 0. We know from our work with the isosceles triangle that this thing was root 2 over 2. Because the adjacent and the hypotenuse are actually the same thing on the isosceles triangle, this is also root 2 over 2. Sine of 30, if you remember, was a half. Sine of 60, I'm going to say is root 3 over 2. Sine and cos of 30 is root 3 over 2. And cos of 60 is a half. So I'm sort of filling in these values here without any real talk about where they came from. So I'm going to talk about that in a minute. Right, so notice first of all that sine's increasing and cos is decreasing. These series kind of mirror each other. As I go from 0 to a half to, upwards. I'm doing the same thing down here. I'm just starting and I'm going that way. Okay. What else? Okay, so now I have to sort of explain why, if I know sine of 30, I know sine of 60. So this triangle is actually one just worth remembering as well. Okay, if I have this as 30 degrees and I have this as 60, this is going to look like this. We know from our work, we know from the first triangle I drew in this video series that, the sine of 30 is a half like that. If I use Pythagoras Theorem, I can quickly verify that this side must be root 3. So it's from this triangle that I can extract all 4 of these values up here. Okay, so I can take the sine or the cosine of 60 or 30 here, and I can get the correct ratios out of that. So that's where they come from. For example, if I know if I want to know the cosine of 60, I circle that, I label the adjacent, hypotenuse, opposite, and I know cos is a over h, so that's 1 over 2. Okay. What if I wanted to know cos of 30? I just did the same thing. I circle the other angle, and I say cos of 30 must be 2, or must be, a divided by h, so root 3 divided by 2, and that's what it is. But here's how you could remember these values as well. Notice that the increase 0, 1, 2, 3, and 4, I could number them as. Well, notice that I can write 0 as 0 over 2. I could write this as square root of 1 over 2, this is square root of 2 over 2, this is square root of 3 over 2, and this as square root of 4 over 2. I think that's something that I spotted a long time ago in one of my classes. I just thought this was really cool. I don't know if anyone else knows much about this trick, but yeah, I'm showing it out here. I think I've seen it actually on a YouTube video before as well, so people have also recognized it, and that's not really that surprising. But this is a good way to remember the values as well, right? And then cos sort of obviously just decreases backwards. So yeah, I just thought I'd share that trick with you, and I would recommend intuitively just remembering the values in this table, because it's gonna make sine and cosine much more comfortable to work with as you do higher levels of mathematics if you just know these values off by heart. And it's really not that much to memorize, right? Especially with this pattern. Or you could just remember to draw the triangle every time until they stick. But yeah,